Okay.
Yeah.
So very good morning to another person here. So we are moving on to the day 5 session 2. The session will be handled by none other than our Sini ma'am, who is right now associated with University College Bahrain. The last time when you see her profile, he is associated with University Coimbatore. Now she has been shifted to Bahrain. So from there only is going to take this particular talk. So without much delay, let me invite Eldos also for introducing the speaker.
Thank you, Shanmir sir. So let me introduce our speaker, Dr. Siniraj P. Has worked as an assistant professor of senior grade at Amrita Vishwa Vidyapeetham, Coimbatore, and currently she is working as a professor at Government University of Bahrain. And in this young age itself, she has got different prestigious awards and honors. She won the prestigious Amrita TBI Innovation Challenge Award in the year 2017 and got secured A+ grade for the big data analysis conducted by Infosys. She is the member of different international associations such as International Association of Engineers and also a member in the Computer Society of India. And she already headed different technical events such as Sanoka, ICPC conducted at the university level. There are 2 funded projects and around 11 reputed journals she already got, and 5 international conferences she is having, and around 6 postgraduate level and 10 BTech level projects is being monitored or guided by Dr. Siniraj P. Without any delay, let me invite Dr. Siniraj for the class. Thank you.
Yeah, thank you, sir. I don't know your name. It's shown as VJCET. So thank you so much, sir. And thank you so much, Shanmugesh, sir. I'm not a doctor yet, okay? That's just a mistake. That's okay. I'm just doing my doctorate and it's in the final stages, okay? Thank you so much, but still nice to hear. Good inspiration. Thank you so much. Okay, so I'll just start on with my session. So
Yes.
what
the sponsor, can you please stop sharing?
Yeah.
Yeah, you can share it.
Thank you. Yeah.
So hope to see you as a doctorate in the next session.
Thank you so much for your kind words, sir. I will also try my best. Yeah. Thanks a lot. Okay. So, so today's session, my plan is mainly, the plan for the whole session is that, because as we had a discussion after the last session. So what we have planned is in the last session, we basically learned about the deep learning applications through IoT. So this time we basically thought we will do more of a hands-on session than of theory. Okay. So, but still, I don't know how many of you are new. So how many of them will be new in this session, sir? Almost
50-50, madam.
50-50, right? So,
yeah.
so I just planned in such a way that I'll just quickly take you through the various applications. So those people who are there, kind of there will be light of kind of a repetition for you. So kindly bear with me. But because when we move on to the experiential learning, when we move on to the practical part, those who are actually new should also be able to go through it. So that's why. So I will what I will do is that I will just quickly take you through a bit of the applications which we have seen in the last class. Then I will spend majority of my time, kind of 1 hour and 15 minutes for or more than that, according to how I finish. Okay. So more than that for the practical session. So that is what I have actually planned. Okay. So hope we will start now. So you all know that everyone knows that IoT is part of your daily life. So the smartphone, smart AC, the smart home, everything is smart nowadays. Even the smartphone which we cannot live with, everything is smart nowadays, right? So this is something, an inevitable part of the life, which we cannot leave it. And it is not we are not isolated from IoT or AI anymore, right? So that is what we are going to see in this whole session all about. Okay. So when we see about the transport, the logistics, the smart cities, so these are all the agriculture, because there are so many farmers. We have already done a lot of experiments and a lot of applications where we help the farmers to identify the the problems in the crop early itself, okay, early itself, so that they could get into the right technique, or they could get into the right medical assistance for the plant, so that we get a better yield later. So all those things are something which we used to see and which we used to deal with in our everyday life. So there are a lot of applications which comes hand in hand. So for those who are new, okay, to this session, I just wanted to take you through, how basically AI and, AI and IoT is basically related. So that's why actually I'm spending a bit of a time in this part. So when you see, this is the same example which I have taken, in the last time. So if when we were kids, when we touch a hot pot, this is because, this example is so close to me, because so many people have given a feedback, that this tells you what, because, there should be a good understanding about what is knowledge, what is data, what is information, what is wisdom. So this information, because this is the fundamental for any AI application. This is the fundamental. So when you start working on with data mining, okay, this is the basic thing, or this is the fundamentals which you have to know, okay, in order to deal with anything and everything in something related to data. So that's why I'm just spending some time on this particular slide. So whenever you touch, say if you are a kid, when you're first time when you are touching a hot pot, okay, when you're touching a pot, okay, which is hot, so what happens? So that touching the pot, the girl going there or the boy going there and touching that hot pot, everything is called as the raw data. So it's like, a binary. It's all like, zeros and ones. Okay, the raw data. But once she or he touches that particular hot pot, he gets the sense. Okay, his or her brain triggers something in his mind and says that, okay, it's hot, and it gets, she or he gets a pain in her in her hand, right? So that is nothing but now an information. Why it is called an information? Because that touching that is the data, and that is now processed, and she got that pain. So that is the processed information. Okay, so sorry, the processed data. So this processed data, when we have raw data, when we process that particular data, that is basically called as an information. Now what happens next time when she or he gets to see a hot pot, okay, there is some collective intelligence or knowledge which is gathered in her mind, okay, to see that, okay, I should be careful, it might be hot. Okay, sometimes it may not be hot as well, but still there is an instinct, or there is something in her mind, which tells her that, hey, be careful, okay, better be careful, otherwise there is a higher chance that you will get hurt. So that is a knowledge. Okay, and then later there is something called wisdom, okay, which is completely unpredicted. Okay, which is completely unpredicted. Say you are seeing a pot which is, we are not able to figure out at all whether it is hot or not. So in such a situation also, you use your intelligence or human brain to understand, okay, whether, okay, I should be careful, okay, if it is hot, then what I should do. So that kind of an intelligence which tells you, okay, if this is the case, okay, what you should do. If that is not the case, okay, what else you have to be done. So all those things comes as an over a long period of time, okay, scenarios which you have never been seen. Okay, so that is nothing but the wisdom. So this is the basic concept which you have to understand when it comes in terms of artificial intelligence. So this is the basic thing. So now when you collect this with when you relate this to the context of IoT, so now you will be able to relate it. So say whenever you are dealing with an IoT application, the first and the foremost thing which you will deal with is the raw sensory data. It could be some temperature data, or it could be some humid sensor data, or some camera data. Okay, it could be some image data. So whatever be the data, any data which we are going to deal with will be converted into some numerical value. Okay, so understand, anything which we deal, say it could be anything, it could be text, or it could be images, or whatever it is, that has to be converted into a raw data. Okay, so that is your raw data. That is just some information. You don't have any idea that what is it. So from that information, you need to understand, okay, how the data is basically structured, or what is the distribution of my data, okay, and what is the maximum which I could understand, for getting the meaning of that data. So what is the semantics behind? Semantics is nothing but the internal meaning behind it. So once you have that, Then you move on to the next level of abstraction and perceptors for better understanding of that, and then you move on to the actionable intelligence, that where you exactly could apply in an unprecedented or unpredicted situation. So that this is how basically you relate an AI with an IoT. So what I really wanted to tell you is that, see, it goes hand in hand. So it is not like it is two different areas, but both of them can go hand in hand. And whenever you see any application, okay, any application like a smart water heater or your autonomous cars, or when you say emotion detection, so we will see a bit of examples, applications later. So in all these applications, when you see, it is not that AI can alone exist, or IoT will exist alone. That is not possible. See, both of them have to exist hand in hand, so that we get some better results out from it. So that is what you have to understand from this whole scenario. So this is so how IoT is related with AI is the first step which you have to have a thought in your mind, so that to get forward. Now, so I will just leave a few of those slides. I will not be going through all the slides, but still. Now, there was a question, wherein, how can you make a, no, a layman? Okay, so how can you explain an AI in layman terms? Okay, or how can you say that, what is artificial intelligence, or what is machine learning, what is deep learning to a normal person who don't know anything about it? Okay, so that was one of the questions which was asked in the last time. So the major thing which you have to understand is that artificial intelligence is nothing but, say, if you are inducing some intelligence, okay, onto a machine, that is artificial intelligence. That's it. Say, if you want to make, say, you have a motor, so you have to go put the switch on. Okay, you have to then you have to check whether the water tank is full. Then if it is full, the water flows off. Then you have to go again, switch off. So all those things are done manually normally, right? But I want to make this whole thing automated. Okay, if I want to make this whole thing automated by simply clicking on a button in my mobile, okay, so by making the motor automated. So how can I make the motor automated? So I am making my motor automated, okay, by inducing some intelligence over to it. How can I do that? Yes, my motor has to know that, okay, the water level in the water tank is low, okay, then it has to fill. So automatically the motor is on, then it fills the water. So once it is filled, I don't want the water to spill off and waste the water resources, so it has to be stopped. So everything is decided and understood by the motor itself, okay, and once it is done, it has to get off. So how can I do that? So you are now, what are you doing now? You are basically making that particular motor an intelligent one. You are inducing intelligence over to the motor in such a way that it acts like a human being. So normally we humans behave like that, right? So if we have something, okay, we think about it, we go there, we understand the different scenarios and the use cases which we will have to consider, and we find out solutions for each and every use cases, and we integrate everything, and we get our solution done, right? So this is what normally we does, right? So I want to induce some intelligence over to the machine, but inducing this intelligence over to a water motor an easy one? No. Okay, I want some. So who is basically doing this? Okay, if I'm making one machine intelligent, who will basically do that? Okay, we have computer and laptops in front of us, right? Who created all this? Basically human brains, right? So we are the basic thing behind all this intelligence, which when we are inducing intelligence over to a machine, we are the one basically behind it, right? So we also know that how to induce it. So what we basically does is that if I want to make my water heater or water motor, okay, the motor to be intelligent, then I need to I need to induce that intelligence. How can I induce that intelligence? Okay, I'm smart enough. We as humans are smart enough to induce intelligence over to the machine by some algorithms. Okay, so I will write some algorithm in such a way that I remotely control. Okay, I train them. Okay, so my water motor should be able to know that, okay, whenever the water level goes say below 10 something, okay, it has to fill up. So something is there. So some training will be given. So normally when we join a company also, we get trainings. So what do they do basically? Say you are trained in one particular domain in various scenarios, so that, when you are put or deployed in a real-time scenario, you will be able to catch up everything and you will be able to deal with everything, whatever is there, right? So it's the same thing here. So we train the water motor with different values, but here we don't have anything else. We just have the water levels. Okay, we just have the water levels to be trained for the motor. So here we train the water motor with different water levels. So when it comes near 8, okay, it should be alerted. Then when it is 10, then it has to start filling. So that information will be passed on to the water motor, and we will train the water motor by using an algorithm. So who basically controls there? Who is actually training that water motor? With the help of an algorithm. Okay, with the help of an algorithm, we will train that water motor, and then we will try giving different values to see whether it is actually working properly. So that is nothing but some testing done. So all these things are induced to a water motor with the help of algorithms built by human beings. So these algorithms are basically called as a machine learning algorithms. So the machine learning algorithm is, as its name suggests, it's not learning of the machine. We are making the machines learn. That's all it is. Okay. We are making the machines learn, okay, by making or training it in different ways, in different scenarios. And as well, we also see that whether our machine is giving us the apt results by testing it with different values. So that is basically done with the help of machine learning. So in artificial intelligence, our sole aim, it's kind of in a big umbrella, okay? It's kind of a broader view wherein you want the machine to be induced with some intelligence. That's all. So how you're going to do that is not mentioned there. So what you have to do is that you can induce that intelligence over to a machine with the help of machine learning algorithms, which are already available. And one more thing which I want to tell you is that, say, I told you, like, when the water level goes below 10, okay, it has to fill up the tank. So there will be so many scenarios, like sometimes, our borewell is dry, so we don't have water at all. So many. So there could be some airlock. So there are so many, challenges which comes in between as well. So we need to train our motor in different scenarios. So the motor is trained using an algorithm which actually takes up different features. Okay, say the water heater, the water tank, the tank capacity has to be taken. Okay, that is one of the feature. Okay, whether I have water in the well, I have to take into consideration. Okay, when the water, the limit is 10 or below, I need to take that into consideration. So there are so many features which has to be considered while training that particular water motor to be, acted in any different scenarios. Understand? So that is nothing but the machine learning. So in machine learning, understand, we are inducing intelligence over to a machine by so and so methods. What all things? Okay, it's nothing but we are writing an algorithm. So algorithm will be written according to what I want that machine to be done. Okay, so that will do. And then I have to give different features over to the algorithm. So as and when I'm extracting more and more features, and I'm making more and more, adding more and more features, my algorithm will train in all the different features, and it will try to inculcate all the different features, incorporate all the different features to give better results. So that what will happen, the errors which is caused by the motor, water motor, which is actually automated one or an artificial intelligence AI powered one, all the errors will be reduced. Okay, and its predictions, okay, when it has to be on, when it has to be stopped, all those things will be, working in a better way. So that is nothing. That is where, so you have a broad umbrella of AI, then comes your machine learning, which helps to induce this intelligence over to the AI, okay, over to the machine. Now, there is something called deep learning. So what is this deep learning then? Okay, it's all, kind of all cousins and brothers and sisters, right? That's all. So in deep learning, basically, what we does is that, say, if any unprecedented or unpredicted thing comes or a situation comes, okay, then also my system should be able to respond to that particular situation as like a human being does. So I told you about an example of the hot pot, right? So in the same way, so even if you are seeing a particular pot where you don't know whether it is actually hot or not, you respond to it in a in an intelligent way, right? So even if your water motor is actually ended up in a scenario where there is no well in the there is no water in the well, or if it is there is some airlock, some different scenarios which could occur only occur as an outlier, like not very often, but only very few times, or something new. So if some such kind of scenarios comes also, our motor should be able to adaptively or adapt to the new situation and able to tackle with the situations which come in the front. So that is nothing but the deep learning. So in deep learning, basically what you are expecting or you are trying to do is that you're trying to imitate the human brain. Okay, so what is basically human brain? So in human brain, you do have millions and trillions of neurons, right? So everything is connected together. Still, I have already told this. Still, a lot of researches are being done, right, upon the human brain. Still, it's all uncertain, right? So in a lot of researches goes on in that. So if you want to extract any new feature automatically, okay, that could be basically done with the help of deep learning, right? So understand, you have AI, then followed by so in AI, what you're basically trying to do is that you're going to induce intelligence over to a machine. With the help of the machine learning, you are introducing new algorithms which will help you to make your machine learn in an adaptive way. And third one is nothing but the deep learning, which helps you to make your machine act or respond exactly like a human brain. Okay, so it will have some collective, so it would have gone through different scenarios. From all the scenarios, if a new scenario comes, it takes its collective intelligence and use that intelligence to respond to an entirely new situation, right? So that is what is being done with the help of deep learning. So hope you are able to identify or differentiate the difference between what is AI, then what is ML, and what is DL, right? So once you have done that, this is a simple example which you could say you have a machine. Okay, you have a machine. So when you see when you show the apple, that machine should be able to identify it is apple, right? So if it is simple machine learning, what happens is that it takes, okay, it is red in color, okay, it is round in shape, so all those common features will be extracted, right? And the machine will be able to identify it is an apple. But say in the case of the app, in the case of the what is that? In the case of the deep learning, you don't have to tell the machine that, okay, it is round in shape, it is red in color, and all those stuff. So if you show the apple in different images of apple for say one or two for a set of trainings, your deep learning algorithm will be automatically able to identify that, okay, it is red in shape, okay, it is something. So it's all something similar. Okay, if you can label it as apple, it will tell you the name apple. That's all. So that is the difference between ML and DL. So in ML, you have to explicitly give, okay, the water level is that, okay, you have to give the features explicitly to the system. But in the case of the DL or deep learning, it's all adaptive. Okay, I have got so and so scenarios before, so maybe this might be the answer. So I will just give it a try. Okay, maybe I will train my system in such a way that, okay, if it is wrong, it's okay. It's okay. It's worth it. Okay, if I make some mistakes, again my system, I give a feedback to my system so that my system learns from it, and again it tries to predict something new. So like that, that it automatically learns. Okay, it automatically learns by itself in the case of DL. Now, so this is this is a common thing which I got from internet. So your feature extraction, then you're learning, but here it's automatic. Okay, your feature extraction and learning is not two different things. It does by itself, and if it has got any errors, it again goes back and it learns by itself. So it's kind of a continuous adaptive learning which is happening right now. So this is something which I have shown in the last class, also in the last session as well. So you have, this is the structure of a biological neuron. And when it comes to deep learning, it's all simple as that. You have an input layer, you have certain hidden layer, and you have got an output layer, as simple as that. And when you map that to a mathematical model, you have inputs and each and every input is basically associated with a weight. Okay, so for this only I told you a beautiful example. So when you're crossing through a garden, okay, so this is for those persons who have not been there, say what this weights is all about and how is the weightage is, how the weightage is actually given to each and every input. So this is as simple as that. Say you are crossing through a beautiful garden, okay, and you have seen a lot of red flowers there, lavender flowers there, yellow flowers there are so many different flowers in the garden, right? Say if you are a person who are so much interested in the red flower, then you will have some weightage, more weightage for that red flower. Okay, if you are a person who is not that okay with the lavender flower, then the weightage for the lavender flower will be lesser. Then if you are okay with yellow flower, then the weightage differs. So this is what is basically, so these are all the different flowers with various your kind of the preferences. These are the preferences for you. Okay, so accordingly the weights also differs. So once you see that, it's a whole picture together. So you add up all the picture, but everything all together, it's so beautiful. So this is kind of everything together. So something is activated in your brain. So say the whole picture is so beautiful of your garden is so beautiful that triggers your brain with, okay, it's that fragrance and everything, so many different features. Okay, the fragrance, the beauty of the the whole garden. Okay, this the sand maybe which is put over the ground. So all those different factors, okay, all those different features are extracted, and that basically activates your brain. Oh, it's all looks very nice. So you get an output like, okay, it is so beautiful. Okay, so in the same scenario, if you're crossing through a rubbish can or rubbish trash or something like that, your output will be something really weird. So according to what your inputs gets, according to the weightage of everything, okay, your brain gets activated in such a way that so all your features are basically extracted, and accordingly the brain activates it and you get an input. So you get an output. So here basically it's like, it's kind of a f of x is equal to y. That's all. So you are mapping something from a domain to a particular range. So according to what your x is, you will get your y as well. So it's as simple as that. It's just like a function, right? So this is whole about your DL, okay, and how it works. And this is an example, okay, which we have seen. So you have, so understand here, the only difference is that see the analysis part and the data analytics parts, everything is all the same. Okay, the only difference when it comes to IoT is that you are working with some sensor data. Okay, so either you will be working with a camera. So even let me be very clear and make it very clear initially itself. See, camera is a sensor when it comes to AI. So when we consider camera, we get a lot of we can get either images or video. So if it is video, we are converting that video into frames. Frames are nothing but say images. And each and every frame, we deal with pixels in the image. Okay, we deal with pixels in the image. And what is that pixels ultimately? Say if it is a color image, the pixels are nothing but 0 to it will range the values from 0 to 255. Understand, this is very, very important. And if you are dealing with a black and white image, you deal with values 0 and 1. So basically, whatever be your input, that input is basically transformed, okay, into a numerical value. Say if it is temperature sensor, okay, I get the temperature values itself. Say, but that temperature value has to be converted into a format which could be fed into the data analysis part. That's all. So that's what. So you get a lot of data here. That data is basically processed and you get your insight. So here, this is the part where you basically use the deep learning, AI, ML, everything comes here. So this is the part where you use your DL. So this big data is basically used for you to store the data, to your Hadoop, your Mahout, the processing. Okay, if you want to parallel process it, so all those things comes here. And if you want to do your analysis and everything, basically that comes here. AI, your ML, your DL comes here. So through everything. So this is your business intelligence or analytics, okay, where you get your data science. So in data science, basically some of the parts comes in the exploratory data analysis, then it also comes to your insights. So it's kind of spread. So all these things are basically related. So understand, IoT don't have its existence by itself, or AI don't have its existence by itself. Everything is related. Okay, so the you understand that it is not that even in mechanical engineering. So because everything, when it comes to your mechanical engineering, you are building machines. But say you are building machines, but that machines are AI powered. That is the only difference. So you build robots, right? You build you built, you know, a lot of, you know, this Sophia, right, whom I have shown here. So this Sophia is nothing but a robot, right? So this robot is basically built by you know, a mechanical. So there are so many engineers who have come from the mechanical background, but there are engineers who have actually from AI background. So there are so many engineers who are from networking background. So many different, it's a beautiful team. So when you explore that, you could understand the kind of the what is that the opportunities which lay outside there for you. So now this is another thing. So in this you could understand that, see, this is a simple example, okay, wherein you get lot of data. So this is nothing but a DL architecture, where you have an input layer, you have some hidden layers, you have an output layer. So once you get the data from some IoT sensors or IoT devices, you need to identify whether it is attack detection, early signal alarming, or normal one. So that is what. So basically, whatever be the application which you are doing, with the help of a deep learning, will drill down to either classification or prediction. Understand? Okay, it will drill down to either classification or prediction, or even when we move forward, it could be even sample generation. Okay, so there are different type of applications wherein you could use deep learning. The most common application where we use deep learning is for classification prediction. Okay, classification prediction. Then another major application is for reconstruction of the data that we will see today. Okay, reconstruction of data, or other one is that sample generation. So these are the different things where we basically use this deep learning for. So understand, this picture is basically given for you to understand that, see, the data, the input data which we are using here are either from any of the IoT devices. That is the difference. Okay, that is the difference from a normal AI to AI in IoT. Okay, so here you could see. So you have to, you know, you have, see, this is nothing but detailed what is that, detailed model of DL. Okay, so these are all the hidden layers, and these are all the hidden layers. So in all these hidden layers, basically you can see there are two different divisions. So one is nothing but the feature extraction, and the other one is nothing but the dense layer. So this is called as a fully connected layer. So this feature extraction will say you have got different data. From the data, you have to extract as many number of features as possible, so that this fully connected layer is a person who basically helps to identify or classify whether it is an attack prediction, early warning signal has to be given, or attack detection has to be done, okay, or it is normal, nothing to worry about. So this classification is basically done. So the business intelligence unit in your whole structure, okay, in your whole structure is nothing but this one, okay, fully connected layer. So this is the business intelligence part. So how it is how it is basically doing that? It is doing that with the help of the feature extraction part, which just comes before, okay, prior to it. So layer, so the input layer is basically, all the inputs are basically passed on to the hidden layers. All these things are hidden layers, okay. But in the hidden layer, the first parts, this parts are nothing but, this is just a convolution layer, okay. I'll tell you that. So this is nothing but the feature extraction part. And from the, once the feature extraction, all the feature extraction, or according to how many layers you have, according to how many, what are the layers in between, okay, the feature will be extracted. So once the feature is extracted, you have a business unit, okay, business intelligence unit, which helps you to decide, okay, or predict or classify, whatever it is, okay, whether what is the kind of the input which is actually given, whether it is actually an attack, or just an early warning, okay, or is it normal. So that classification will be done by this particular part. So understand. So this is the major structure for any AI and DL. Okay, so AI and DL. Okay, now moving over to, I will just quickly move on to a few applications. So these are something which I have already told. This is just for those persons who are new. I will not be going very detailed onto all the applications. I'll just touch upon, okay, these are all the areas or the applications, so you can work over it later. Because for others, otherwise it will be a repetition. So the first one, which application which is very commonly used in IoT and AI, is that self-driving cars. So when you say about the self-driving cars, understand there are so many sensors which is used. Just understand when an automatic car is there on the ground. So I think you would have already seen about various demos and everything related to it. So that's why I'm not repeating those demos. Our mentor and a team would have already shown this. So that's why I'm not repeating all those. Okay, so basically in an autonomous car, okay, when you see an autonomous car or a self-driven car, so if the self-driven car is on the road, okay, what are the scenarios which we need to consider? Okay, it has to look over to the front and it has to look over to the side, because a lane change can happen. Okay, and sufficient distance has to be maintained between this car and the car at the front, right? So there are so many scenarios which has to be considered, okay, when an autonomous car is there in the road, right, is on the road. And especially in the cases like in Indian scenario, the roads like Indian scenario, when we say where the diagonal cuts are very common, right? So suddenly the razors will be there, the zigzaggers will be there, so there will be different kind of persons who are there on the road. So for all those scenarios, the alerts has to be sent to the driver, okay, or not the driver, the car, okay, and the car has to react to the different unprecedented scenario in the proper way, right? So that is a challenge which you could see. So let me tell you, this geo mapping, the identifying the paths, the signal, so all the things are still an area of research, and still there are a lot of works which are happening. So when you are building a particular model, okay, understand what all will be the different test cases that has to be considered. So how will you understand that? You will understand that when you are actually in that particular scenario. So you take a car, you drive, then you drive to different scenarios, then only you'll be able to identify the different test cases. So there are so many research which are happening on, and Uber has come out with a different research wherein they are developing this self-driving cars just to replace the applications like Swiggy. So wherein there is a bigger statistics which is shown that when the people like Domino's and the Swiggy is going to deliver the food, because we all need to eat hot foods, right? But what happens is that by the time they rush over to that, and they cause a lot of accidents to the other people, and they themselves end up in a lot of accidents. So the statistics is too big, so they are actually coming out with autonomous or self-driving cars wherein they could replace such kind of applications. Okay, then the next one is nothing but emotion detection. So in emotion detection, there are so many things. So in emotion detection, what is the sensor which we are using? Yes, the major sensor which we are using is nothing but the camera, or the camera wherein you are capturing either the video or the images. So if it is video, that video is basically converted into images, that frames, and the frames is again taken as considered, then it's all the same. So then it's 2D, right? So this is how the things happens. So then another application is in the natural language processing. This is entirely a different area of research, but here where IoT touch-ups on is, basically say when it is voice to text processing or signal processing comes in. So it's all about, the speech sensors, the various sensors which you will use is nothing but everything actually comes as part of the IoT. All those things are sensors. And understand when it comes here, the major algorithm, there are different type of algorithms available. But here the major type of algorithms which we use will be convolution neural network. Then how we represent the data, like there are different type of word representations and embeddings available, like globe, word to vec, doc to vec, node to vec. There are different type of things available. So everything will come in picture from deep learning here when it comes to this natural language processing. So this is also an important application, and this is kind of a different area as such, or I could say a different part of the ocean as such. Okay. And then comes the virtual assistants. So in virtual assistants, you would have already seen your kids speaking with the Alexa, Google, okay, Google, and all those stuff, or you have your virtual assistants on your phones, who takes care of everything, what all your, say nowadays you have even seen in the Outlook mailbox, the Cortana sends you, the messages like which you have to definitely look over to with high priority in a day, right? So all those things are basically your assistants, okay? And then comes, so I'm just leaving all those small examples. And then your Google Assistant, yes. So all those things. Then comes to entertainment. When it comes to entertainment, you have your Netflix, Amazon Prime, everything. So in all these things, okay, how basically it does is that, say the National Basketball Association, NBA, long back they did an analysis upon the video of the play which has happened long before. So what they have done is that they have actually captured the whole video and they analyzed. So they captured the video of the same players in different basketball courts, and they analyzed the video in such a way that to understand, okay, how each player plays in different codes, okay, how each player plays when the opponent is so and so person. So this is basically happened in long back, okay, long back, where this from there basically what happened is that they have actually come out with a new area called deep video analysis. So this deep video analysis is a heavy task. Why it is a heavy task? Because say you are not going to see say 1 hour video or 2 hour video. So if you want to analyze and get your algorithm predict in the most efficient way, then you should make your algorithm, okay, train the system by using hours and hours of video. So this so it is basically a tough task, okay. It is basically the computational the constraints which is there upon the system is too much, okay. That was one of the applications. So that was one of the applications which has been done in terms of, that's one of the what is that, lot of lot of opportunities are there and still there, okay, in terms of entertainment in this particular section. And then comes to this this wonderful, this is actually a project, okay. This is actually a project which we have seen, okay, in the Science Direct, from the Science Direct it is. And so this is actually done by Andrew Owens. So what they have done is that now you have a lot of this things called trolls coming in, right? So what basically does is that you will take the picture of or the video of one particular person and you are mapping it to another person. So you are basically, you know, clubbing it. So that is basically done by something called generative adversarial networks. Okay. So when, you know, otherwise you could do manually using Photoshop and different tools, but how that tools work. Okay. So that's kind of a merging which is there. But otherwise, if you want to make the deep learning work upon such kind of videos, that is possible with the help of LSTM RNN networks. And the other one is that, you know, by using the GAN. So GAN is nothing but generative adversarial networks. So there are some latent models. Okay, so all these things are basically possible. Okay, so you're capturing a video from a camera sensor. So once you capture that, you get your data there. Then you are actually getting the voice sensors, so voice from the sensor data from the voice sensors. Then you are trying to map the data from the camera sensor and from the voice sensor. That is basically happening here. Okay, so that is actually possible with a lot of deep learning algorithms. And even by using, if you are using GAN, okay, the generative adversarial networks, you know, you will be able to generate even new samples, okay, so in such a way that, you know, new videos, okay, new videos. When you're seeing that new videos, you will not be even able to identify whether it is fake. Okay, that means that your algorithm will start producing voice to a silent movie exactly in such a way that you will not be even able to recognize that that movie has been merged with or overlapped with some other voice which is not its. So it is very difficult for you to even identify. So that is the beauty of the deep learning algorithms when it comes to this. So this was such a kind of the work. So this paper, if you are really interested, you could just go ahead and even the YouTube video. So the complete working of this video, everything is actually given by the author, Andrew Owens. Okay, so you could just go and go back and have a look over to it. It's really beautiful to look over to it. Then comes, one second, yeah. Then comes the visual recognition. So this is something which, you know, you would have already seen this application when you are in the traffic light and see if you're waiting, your car is waiting in the traffic light and all, right? You would have already seen. So even if it is an autonomous car, the car should be able to know that, okay, if it is a traffic light, okay, it has to stop, right? And at the same time, if you want to do a traffic analysis, okay, you need to identify at which time of the day, okay, more number of actually car or the vehicles has been actually passed, okay, and which is the kind of the vehicle that has passed at which hour of the day, okay. So all those analysis could be done with the help of visual recognition, okay. And then The next one is okay, the developmental delay, because which comes in the healthcare sector. So in healthcare sector, basically there are different type of applications, okay, and the major applications still which is going on very high is related to the cancer images, okay, the cancer images. So when you are giving them your deep learning algorithm the cancer image, it has to identify whether it is actually benign or malignant, okay. Even my mentor has done a particular application called Kaya, okay. It is nothing but you the images which is trained by the system, it will help you to identify whether you have skin cancer or not, okay. So those are different type of applications which could be done in the healthcare. Then another part is nothing but, so this is kind of image recognition. So when you get some images from the camera, you could take that and you could analyze that. Then the other one is nothing but as an aid for the children who have got developmental delay, okay. So if how can you help this IoT and AI to help the kids to grow in a better way? How can you make their lives easier? Okay, so that is basically done by a lot of different algorithms like residual analysis and different kind of course correction, the parts which could be done so that their life is so easy and fine. So there are so many what is that see, from children to children, their delays and their kind of the response to the system, everything differs. So you need to basically say, if you're building one particular system, that system has to be trained for that kid, okay. So each kid respond to a particular system, okay, or a particular model in a different way. So it's kind of a lot of challenges which comes in that. So still there are a lot of researches which are happening in this particular field itself, okay. So you need to identify how the child responds to each one. So you have a camera which identifies the kids movements. So you need to first train your system in such a way that by capturing the lot of videos of how the child walk, how the child respond, how the child speaks, so voice. So there are so many sensors which are involved in it. You need to collect the data and you need to feed it onto your system. You need to identify, and then that input has to be given to the model, which helps this kid to respond to the system, okay. So many there is a lot of challenges which are involved in this particular area of research as such. And this one I'm just moving. Then the other one is automatic machine translation. So you would have already seen this as your Google Lens. The other way around, this is the vice versa of this, you would have already seen, not a variant of this. So in Google Lens, you could see that, if you are actually taking an image with the text, okay, you could see that image will be extracted and the text will be extracted, and according to the text and the image, you will get a lot of Google search results, right? So in the same way, this is another kind of application wherein you're simply giving some descriptions. Okay, there is a bird with an yellow beak and with a black feather, something like that. Then it creates picture. So this is kind of the GAN. Okay, so whenever I say GAN, it is also combined with your it could be combined with your RNN and LSTM, which will help you to come out with the images generated according to the text which is given. And it could be vice versa as well. Say if you are giving an image, okay, that from that image you need to identify there is a red feather and a blue feather, okay, and there is a blue eye. So all those information has to be extracted and it has to be converted into a text. Okay, so whenever it comes like this, so all these things are different applications which comes in there. And then fraud detection, and then personalizations, news. So this is another application which you could see where you have seen your grandparents' old photos taken and it is converted into a colorful image, right? So that is all done with the help of deep learning. That could be automated with the help of deep learning. Then another major area of research is handwriting generation. Say there is an application which is done by my mentor. So wherein what he does is that he takes a lot of applications. Say when you fill up the applications, say when you want to enter into a college, you need to fill up the applications, right? So all this application has been taken. So when you take that particular application, in that particular application, you will have a printed section and you will have a handwritten section. So your challenge is to just identify the handwritten section. Okay, so that handwritten, so that is actually fed onto the model as images. Okay, and then that handwritten area alone is selected, and from the handwritten area you need to come out with the transcript. Okay, what it is basically. So what and understand, you should think, and each a simple capital letter A or a simple small letter A can be written by me myself in 10 different ways. Hope you could understand at least 10 different ways, or at least to 10 to 15 different ways. So just understand the kind of the permutation and the combination when it comes, okay, when you are going to train a particular system with the handwritten, handwritten material. So that's the kind of the challenges which you actually face when you deal with such kind of situations. But still, a deep learning algorithm, if you train it and if you train it in the proper way, that system would be able to adapt to a particular situation where it could identify, okay, what you have actually written, and it will be, it will give you sorry, it will give you the exact transcript what you have actually written. So all these things are applications which you could do. And this is basically the translations. Say you are writing something in different, or you have an image, okay, in different language, that language has to be converted into, so this is kind of your Google Translate, okay? So you're translating from one language to another language, okay? So you have to extract each and everything. Then that has to be converted into the, say, different language. So this is basically translations. And then pixel restoration. So pixel restoration is another thing. So why I tell all these applications is there are a lot of applications. See, all those applications which I'm telling here itself is a different area of research. It is just telling, like, they are using some pixel recursive super resolution method, but you have various, options available out there for you to explore in this each and every application. So each one of this is again, vast kind of ocean in front of you. That is what I'm trying to tell you. This is just kind of a bird's eye view for you. That's all. But when you go deeper, you have n number of problems and n number of opportunities available out there for you to explore. So photo descriptions. So there is another beautiful project which is done by one of our colleague, where he was actually trying to build a system for the visually challenged persons. Okay, so they are visually challenged, right? So they will not be able to see. So, but still they should be able to, they are actually given assistance with the help of the robotic arm to pick up the right thing. Okay, whether it is where is the tea box? Okay, where is the water can? So everything will be assisted in with the help of an assistance system, and that will be, so there was a system which was built by them. So there are a lot of opportunities available out there. And then deep dreaming, if possible, if time permits, I could show you this example. Otherwise, I will just leave it. Okay, this is a beautiful example which we ourselves could do. And this is all these examples are are actually available as apps also. Like how a girl has how a girl could be transformed as boy. Okay, how Obama's the younger age to the older age, the transformations, right? When you become old, how will you look like? And this is kind of the deep dream. So all these things are basically done by using latent models. Okay, latent models, when you tell latent models, it's all about generative adversarial networks, then variational autoencoders, and the autoencoders, everything comes in picture here. So that's all. So I think I'm almost kind of 1 hour left, and I could go take you through the applications. So before moving to that I want to tell you that there are different algorithms. Okay, there are different kind of algorithms which are available in IoT. Okay, but the major algorithms which are basically used in IoT are, one is that CNN. Okay, so CNN is kind of ubiquitous when it comes to the computer vision area. Okay, so whenever there is computer vision, CNN is there. So that is kind of the impact of CNN upon the images. So you should always understand, as you are IoT or you are trying to learn IoT, always understand when we deal with images, we are dealing with camera sensor. Okay, from the camera sensor, we capture images or videos. If it is videos, we are converting into frames, or if it is images, we are working on images. So that is the kind of the relationship, how IoT comes in. You have to keep in mind when we are going through all this different algorithms. So the first and the major algorithm which we basically deal with is convolutional neural networks. Okay, which is basically the best one among the algorithms for images. Okay, and when it comes to RNN, it is recurrent neural network. So it is an algorithm who has got memory, or who has got the memory power. So it's kind of like that. So it has got a memory. So when we say in terms of memory, when you drill down to its basic knowledge, you should understand that they're all gates. Okay, your gates, AND gates, NOR gates, and everything, who helps to who helps the system or the model to remember things. Okay, please understand like that. So it's all kind of, the NOR gates and the OR gates, XOR gates, okay, which helps, okay, to help the system to remember something. Okay, so it has got memory. So, and basically this RNN is basically used. So RNN's variants are LSTM, and you have got gated recurrent units. Okay, so that is nothing but GRU. So all these algorithms are basically used when when the text part comes in. So if you're going to deal with textual data, so RNN is the best. But that doesn't mean that you cannot use RNN upon images, because say I have an image with a text, then I can even use a combination of CNN and RNN, say LSTM, to identify, say, because I could say that, for the I told you one application which my mentor has done, right? So where, the application is taken. So that application, basically all the applications are fed into the system as an image for us. So we basically used a CNN combined with an LSTM network, okay, in order to identify, extract the data and identify the text out from it. So it's all kind of combinations again. But still, when it comes to pure textual data, we basically go for RNNs. Then comes the auto encoders. Auto encoders are very much needed for IoT applications, okay, because auto encoders are basically those algorithms, okay, it's a latent model. So those algorithms which helps you to identify the distribution of the data, okay, which helps you to identify or reconstruct your data. Okay, say I have an image, okay, when I'm passing this image through an auto encoder, I get the same image. Okay, I get the same image that we will see later. So I have an image, my output is also the same. Then why do we use this? But the output which I got is a reconstructed one with a lower dimensional data. So it is either in a lower dimensional space or in a higher latent space. Understand? So we extract the data, okay, we extract some features from the original image, and we basically map it to either a higher dimensional space or a lower dimensional space. So if you're mapping over to the lower dimensional space, you could either use this auto encoders for PCA, so dimensionality reduction, okay, purposes. So that is basically, because say if you have large amount of data, then the data as such cannot be processed. So you can better use the auto encoders to identify, say if you're getting a blurred image, you need to understand what that blurred image is. I don't know whether you remember when what is that? There is a film called Virus in Malayalam. Okay, so in that film, they were able to identify. So you could map that. So you okay, so that they were able to identify with a lot of difficulty. So all those kind of things basically. So that is kind of an image. That's a blurred image. So such kind of an image, which is completely in a low dimensional space, or it's completely so. From that image, if you want to reconstruct what it is, okay, basically you can use such kind of algorithms like autoencoders or generative adversarial networks. And then generative adversarial networks, when it comes in picture, it's all about, you could generate new things, completely new data. Say your data set is really small, but I need more data to train my system, but my data should be exactly similar to the original data which I have. Then better use generative adversarial networks, because these networks will help you to generate data as close to your original image, okay, so that you don't have to worry about how it works. And then comes reinforcement learning. Basically, this reinforcement learning comes as part of the machine learning. But reinforcement learning, the beauty of the reinforcement learning is that in IoT, the beauty is that it's kind of it gives you punishment if you're not doing well, and it actually inspires you when you does well. So it's like that. So it's kind of you have a feedback which is always gotten in such a way that you can improve your system. Either if you're doing something negative, okay, a punishment has to be, a penalty will be given to you, so that you have to train your system in such a way that you do well. So that comes in the reinforcement learning. So that basically comes as one of the division of your machine learning: supervised learning, unsupervised learning, and machine reinforcement learning. But the reinforcement learning is also used in IoT applications. And when you see there are a lot of IoT security applications, okay, wherein the DL algorithms are mainly used. So that's why I have given this particular paper. So you could just go through this paper. This is such a wonderful paper, okay, a survey paper on IoT security alone, okay. Such a detailed paper which tells about which all DL algorithms could be used on which all scenario. So please definitely, if you are really interested in IoT and DL, okay, and especially in security scenario, okay, then you have to definitely go through this survey paper. It will be really helpful for you. So moving over to, okay, because we need to try some a new demo and everything. So just for you to understand, so I will not be going very deep into each and every algorithm. I'll be telling you what it is and I will show you the demo. That is what I have planned. Okay, in CNN, it is the convolution neural network. So as I told you, any image, it takes an image. That image, I told you, it is basically considered as a pixel, right? As a set of pixels. Say if my image is basically 165 by 165, and what is this 3? This 3 is nothing but it has got 3 different dimensions. That's all. Say if it is a single black and white image, then it would have been 165 by 165. That's it. Otherwise, if you have RGB combinations, then it will be represented like this. So in your CNN, there are 2 different parts. Okay. The first part is the feature extraction part, and the second part is nothing but the fully connected layer. So this I have already told you. So in the feature extraction part, you have certain operations which could be done in CNN. Okay. The first operation which you could do upon the CNN is the convolution operation. Okay. So one is called as a convolution operation. So what is a convolution operation? So from there only, actually, this convolution neural network got its name. Okay. So convolution operation is as simple as that. Okay. So say if you're taking this particular image as a matrix, okay, consider this particular part of the image, this whole thing can be considered as a matrix. What you're going to do is that you're going to convolve this image. Okay, how are you going to convolve this image? You're going to convolve this image with the help of a filter. Okay, what is this filter? Filter is again nothing but square matrix, which is of which is nothing but a matrix. Okay, so what I'm going to do is that I'm going to apply a smaller matrix upon this matrix, okay, upon this bigger matrix, and I calculate the value from the matrix. Okay, I try to integrate the collective value from this, and I will form a new matrix. Okay, so this value, the small matrix, will be applied upon the whole of this part of the original image, and once it is applied, this will be moved. This window will be moved like that. Say 1, 2, 3. Say if you are actually considering this as 1, 2, 3. So 1, 2, 3. Your filter is basically having 1, 2, 3, 4, 5, 6, 6, 7, 8. Right? 9. Right? So there are 9 small cells. So this is the first part wherein you apply. Then again you will apply on this part. Then again you will apply on this part. So you will move the filter upon the image both from left to right and from top to bottom. Okay. And finally, you will get a new matrix, which is nothing but a smaller matrix, which incorporates all the high intensity values. Okay. So why do we need this high intensity values? Because say, this is our original image. This original image, from this original image, say if we want to identify this lady is smiling. Okay. This lady is happy. This is what I mean. I want to identify. So from this particular image, I will apply a filter in such a way that that filter helps me to identify that this lady is smiling. Okay. So how do you select the filters? You select the filters in such a way that according to your application, you select your filters. Okay. Are there different type of filters? Yes, there are so many different type of filters, which is already done and kept ready for you to use in your application. Okay. So you need to use the exact filter for your application. Okay. And the features will be extracted. Now there is something called max pooling. Okay. And there is something called activation layer. Okay. I will show you all this. So this is the kind of the feature extraction. So what do we do with all this, ma'am? Yes. So can we have multiple convolution layers? Yes, you can have multiple convolution layers. You can have multiple max pooling layers. You can have multiple activation functions. So what will all these do? Yes, understand all this will help you to extract the features as much as possible. So once you extracted the features as much as possible, then what will you do? You have a fully connected layer. It is otherwise called as dense layer, which will help you to identify, okay, whether she is happy or neutral or angry or whatever it is. So I'll just quickly go through this. So this is the convolution layer. Okay, this is the convolution operation which I was trying to tell. Okay, I know it was so vague for you. So this is your original matrix and this is your filter. So what we basically does is that we get this first value and we get this value. So 1 into 1. Okay, so this is the original. This one is basically the original value in your main image. And this one is nothing but the value from the filter. So what do? You apply everything upon the, so everything is multiplied. So 1 into 1, 1 into this 0, then 1 into this 1, everything is multiplied. Then you will do a summation. That's all. Okay, you will do a summation. And what will you get? You will get 4. So like that, then what will you do? Then you will slide this filter upon to the next set, this one. Then again you will slide here. Then again you will slide here from top to bottom. So you will move from left to right and top to bottom. So what will you get? After everything, your complete matrix will be filled here with values. So what does this 4 represent? This 4 represent the collective intensity of this particular part when this filter is applied. So say if you are trying to identify that lady is smiling, we will get a real high intensity value which will help us to identify, okay, that is smiling. So this is kind of a feature extraction. This is the first level of feature extraction which could be done. Okay. And then what will a pooling layer does? Okay, so this is basically, the next one is nothing but the activation function. Okay, there are different type of activation function, and basically when you do programming, this activation function is basically comes as part of your convolution layer. Okay, understand? I'm telling about various layers which comes in the convolution neural networks. Okay, the first one is nothing but the convolution operation, wherein your output will be a convolved feature map. Okay, then this convolved feature map, this is the convolved feature map. This convolved feature map will be the input for your activation function. Okay, so what is the activation function which we are using here? Okay, this ReLU. Okay, don't worry about all this. So this activation function, what it does is that it limits your values between a certain range. So it is exactly like your f of x is equal to y, where my x is equal to 0, then my y will be some certain value. My x is equal to 1, my y value will be certain. So I'm limiting my whole values between a certain range. So you could also say that I'm understanding the decision boundary of the image. So what you does is that you will apply this ReLU upon the convolved feature map, and you will get a feature map which identifies the output. Okay, so this is nothing but the output of the rectified feature map. So in rectified feature map, you could see they have actually identified this white color thing. Okay, the white color border. This is nothing but it identifies the decision boundary. Okay, this is the beak. Okay, this is the neck part. Okay, this is the tree part. So all those things are identified in the rectified feature map. Okay, it is not only, it could be any activation function feature map. Okay, whichever activation function you are using. So in activation function, when you are applying the activation function upon the convolved feature map, understand it identifies the decision boundary. So once you do that, then the next layer is nothing but pooling, your max pooling. So what will happen in max pooling? In max pooling also, what you does is that you will apply filters. So understand this convolution layer, this convolution operation layer, then followed by this activation function, followed by the max pooling. Everything is done for feature extraction. So understand, in pooling, what it does is that it will apply filters which are even more refined. Okay, so I will apply filters which will identify the edges, which will identify the body, which will identify the feather, okay, the beak. So I will apply filters in a more refined fashion in such a way that it identifies even more finer details from the image. So this is nothing but the pooled feature map. So when you have the input for the pooled feature map is nothing but the activation function feature map. Upon the activation function feature map, you can apply different type of pooling techniques, that is max pooling, sum pooling, average pooling, different type of poolings. Okay, so once you apply the pooling, so that is again a matrix, that is again a filter, that is again a filter. So when you apply that filter, you will get even more refined image. Okay, so say you can say that, okay, this is the pooled feature map and this is the matrix representation of it. So when you have this matrix representation, the next step in your convolution neural network is nothing but flattening. So what is this flattening? This is a small operation which comes in between your feature extraction and the fully connected layer. So what it does is that, say if you have, so understand, say you have the 6, 8, 4, 7. So all these things are nothing but the high intensity features which will help the fully connected layer to understand, okay, what features has been extracted. That's all. Okay, so these are all the values. So this multi-dimensional data is just converted into a single is there, 4 is there, 7 is there. So this is the next operation. Then comes, so once you get the flattened matrix, this is your flattened matrix. Okay. So once you get that, then you are passing those information over to what? Over to the fully connected layer. Okay. So once you are in the fully connected layer, what you will do? Okay. You can identify this fully connected layer will help you to identify whether it is bird or dog or cat or whatever it is. So it identifies you with what exactly that image is. So understand, in CNN, you have two different set of operations. One is nothing but you have hidden layers, which will help you to identify the feature or to extract all the features. And then you have a small operation which comes in between, which is nothing but the flatten operation. Then you have a fully connected layer or dense layer, which will help you to either classify or predict what exactly the image is. Okay, so this is what it is. So I'll just quickly move on to the demo, which will be more useful for you. So before moving over to, sorry, not this one. So before moving over to the demo, I want to tell you a small thing that is related to the tools. Okay, so understand, if you want to do the operations, or if you want to do the practical demo of this, there are basically two different ways. Okay. The first one is nothing but the conventional way of doing it. So you could install the Anaconda. Okay, the Python 3 has to be there, and Anaconda has to be installed. Then Jupyter Notebook has to be installed. And the other way is nothing but by using the Google Colaboratory. Okay, so if you are basically going for the first option, okay, what you basically have to first check is that your system should have proper configuration, at least by i5 processor and above, and 8 GB RAM, 64-bit OS. So if you have all this, then you could install, then you could go for the option 2. The option 2 is nothing but you have to install Python 3, then Anaconda 3 distribution. Upon that, you can have your Jupyter Notebook, then you can install Keras, TensorFlow, all those things, right? And if you don't have this option, then you better go for the next option, that is nothing but, so this is the detailed explanation of how to install everything. Okay, then otherwise, if you don't have all this, then better you give the load over to some external server. That is nothing but you can use this Google Colaboratory, where what you could do is you just need an Gmail account. Okay, so you just need a Gmail account for you to use this particular Google Colaboratory. Okay, this is just the next option. So understand that there are two different options, or there are multiple options, but I'm just telling you two different options. So either you could go with the typical way of installing everything, installations done. Okay, or else you could just start. If your system is really slow and you don't want to take the burden, then better go for the Google Colaboratory. So these are the technical details which I want to tell you before moving over to what you have to do. Now, moving over to the demo. So I will tell you a first example. This is the same example which I have taken last time. So I just want to tell you very fastly over to it. Just scroll on fastly over to it and understand what it is. So here. Once again, I'm just taking a folder. Yes, so say in this particular example, what we are going to do is that by using CNN, we are going to identify whether the picture which we are going to give is cat or dog. So that is our aim. Okay. So what we basically does is that in this, we have got a training data set. Okay. So the training data set which has got, so this is the test data set. So you have got two folders. One is the cat and one is the dog. Okay. In the cat folder, you have got almost around 1,000 items. And in the dog folder also, you have got almost around 1,000 items. Okay. And you have got a training data set. Again, you have two different. So it's kind of a binary classification problem. Okay. So you have cats where you have almost around 4,000 images. Okay. And here in the dogs also, you have got almost around. Okay, sometimes my system gets hang because all this, yes, it's not responding. So see in the, okay, so here also you will have see almost around 4,000 images. So you could just understand your training set basically has got almost 8,000 images. Okay, so this is the whole scenario. And now what are we going to do? We just wanted to identify. So we are going to build a CNN model And ultimately, when we give this particular image, my model should be able to tell you that this is dog. Okay. And when we give this image, our system should be able to give us it is cat. So this is the first one. So now understand. So I'll just quickly go through so that those who are new to this session should also be able to benefit out from it. So understand, the first thing is nothing but, so I'm going to use the conventional way of doing things. So I have my anaconda running behind. See, I have my anaconda, and from the anaconda I have actually used the Jupyter. I have opened the Jupyter notebook. Fine. So I'm going the conventional way. So what we are going to do here is that we are going to build a convolution neural network model. Okay, neural network, which helps that model should be able to identify whether it is cat or dog. So for that, there are basically different type of frameworks which are available. Okay, so there is a TensorFlow framework which is available, and there is another framework which is available called as Piano. Okay, and there is also something called PyTorch or PyTorch, which you could. So basically, I am a person who used to work with PyTorch. Okay, and also the other one which I am very okay working with is TensorFlow and Keras. Okay, that is a common one which I used to, because PyTorch, the packages, everything is a bit different. So we should have a different session if we want to explore that. So here in this particular session, I'm not switching. I'm just using, TensorFlow and Keras. Okay, so understand, Keras is kind of a neural network library which actually which is built upon TensorFlow. Okay, so it actually gets the it actually gets a benefit of using both the TensorFlow packages and the Keras packages all together. So it's something kind of a deal which is there between Keras and TensorFlow, where you could use both. Okay, so in Keras itself, when you see, there are certain functions there are a lot of functions which are inbuilt functions which are there. So understand, when you are building a convolution neural network, you have already seen that. Okay, you have already seen when you are building a convolution neural network. Convolution neural network, you could see this is the first layer, then followed by max pooling, then again followed by convolution layer, then again followed by max pooling. It just goes on like that. So it's like you have a big box. Okay, you have a big box. You're going to put each and every layer one by one. Okay, so once I have built this particular model, as a convolution neural network model, then I need to follow the sequence. That means when the input is given here, the first it has to go through the convolution layer 1, then it should go through max pooling, then it goes through convolution 2, then max pooling. So there is a sequence which has to be followed. So there are different type of models which are available in Keras. So here we are basically importing the sequential model. That is what I wanted to tell you. Then the next one is convolution operation. Do we need to build the convolution operation from scratch? It is not needed here, because there is a function which is already available in Keras as con2d. Okay, as con2d. So if you go to keras.io con2d. Okay, so keras.io is a site, once you start working with this, will be one site, which you will have to go very frequently. So this is, everything is actually given. Everything is given here. So see here in Keras in the layers, because this is a convolution layer which we are going to add in our black box, right? So, and that actually comes as part of the layers. So in this con2d function, you could see there are different type of parameters available. Do we need to give all these parameters? No, we need to give just the needed parameters. So when you see here, you can see the examples for each and how to use each and every parameters out there. So that is the beauty of this keras.io documentation. Okay, so here, understand, we don't have to implement the convolution operation from the scratch. Instead, we just need to call this particular function and give the needed parameters to this particular function. Then the next one is nothing but max pooling. So you already know that in max pooling, we are applying filters, and that too filters which are more refined. Okay, so that is also already available. So you need to just import it from keras.layers. Then what is the next operation? The next operation here is nothing but you have a flatten operation. So once this is done, then here this part is nothing but this is a multi-dimensional data. This multi-dimensional data has to be converted into a single dimensional data. So there is a small flattening operation which comes in between. Okay, there is a small flattening operation which comes in between. See here. So these are all the different layers. then this is your flattening operation which comes in between, right? So you can call the flatten. You don't have to do that operation. You have to simply import that particular operation. Then what is the next one? The next one is nothing but the fully connected layer, or it is otherwise called as dense layer. So do we need to implement that? No, we have to just import that layer from keras.layers. Okay, so this dense layer is nothing but the fully connected layer. And then there is another beautiful operation called another beautiful what is it? This is a function called image data generator, which is basically comes in keras.preprocessing.image. Okay, that means this will simply help you to modify your image. Say if you want to rescale your image, because say if you're working with a RGB image. So I already told you in RGB image, all the values, all the pixel values will range from 0 to 255. Okay. But say if you want to process it with the help of a deep learning algorithm, that has to be converted into 0 to 1. You have to normalize that image. Okay. Then only you will be able to work upon that particular image. Say if you want to do some particular operation upon the image, then you need, say if you want to normalize a color image into a black and white image, okay, then you need the help of image data generator in order to convert it into a normalized one. Okay, sorry. So this is nothing but this image data generator is all about. Hope you understood. So all the things which you have seen just now here, whatever you have seen just now, you don't have to implement anything. What you have to do, you need to simply call them in the right way possible. That is the only thing which you have to do. Understand? So now we are going to build the model. Okay, so now we are going to build the convolution model. Okay, is it a rocket science? No. Okay, so the first one is nothing but you already decided that the model which you are going to build is sequential, right? So what is the name of the model that you're going to build? The name of the convolution is, whenever you hear the name classifier, that is nothing but what? The convolution neural network model which you are building. Okay. And what kind of a model is that? That model is basically sequential model. Hope you're able to understand this line. Okay. Okay. And then next one is nothing but, I told you, you need to use what? Convolution 2D, right? So what is convolution 2D? Convolution 2D is nothing but it will perform the convolution operation upon the original image. So what is your original image? Your original image, say your cat and dog image is 64 by 64, 3. What is that 3? 3 simply tells you it is an RGB image. Hope you are able to follow me. Okay, hope you are able to follow me. So 64 by 64 is the dimension of the dog image. And this 3 will simply tell you it is an RGB image. Okay, so you have taken your input image. Now what you have to do, what is the other parameter which you have to give? How many filters you are going to apply? See, in a convolution neural network, one second, in a convolution neural network, when you see here, it is not that you are applying just one convolution operation. You are applying different filters over to different filters. So there are so many different filters applied so that all these filters will try to extract you what? The features. So that is why we have actually given a number here as 32. This 32 will tell you the number of the filters that you have applied upon this particular layer. Hope you are able to follow me. Okay, so this is the number of the filters. Now, what is this one? This is nothing but size of the filter. Okay, that means I am going to apply 3 by 3 filter. How many 3 by 3 filter? 32 3 by 3 filters. So how my convolved feature map will have how many outputs? 32 convolved feature maps I'm going to get. I hope you're able to follow me. Okay, now the next one is that, okay, I told you the activation function will come along with the convolution layer in case of coding. Okay, when it comes to coding. So what is the activation function they are using here? They are using this ReLU, so rectified linear unit. Okay, so the beauty of this rectified linear unit is that, say if you have values, the negative values, that negative values will be nullified, and it will be what is that? It will limit that values from 0 to the maximum value. Okay, so that means in your image, you will get a non-linearity of image. So I'm not going into all details. So just understand activation function is something which will limit your values to a certain range, say 0 to maximum or -1 to 1 or 0 to 1 or something like that. Okay, it will limit your values between some particular range. So that is what, or it will help you to identify your decision boundary of your whole image. Okay, so that's what is this activation function is all about. So I told you this is your convolution layer. So in your convolution layer, you're simply calling the function convolution 2D. Okay, and then it gives you 32 filters are used, and this is the size of the input filter. Okay, and this is the your original image size, and followed by the activation function. Now, what is the next one? Next one is nothing but max pooling. So I told you in max pooling, what are you basically doing? You are again applying filters. Okay, what kind of filters? Those filters which will be able to even refine and get me more features from the rectified feature map, right? So that is what is happening. So here, what I need to give, I need to just give the filter size. Okay, whatever be the filter size, that filter size has to be given. Then what is the next operation? The next operation is nothing but flattening. So what will happen in flattening? In flattening, what you basically do is that you are going to convert your multi-dimensional data into a single dimensional vector, right? So that is what you are doing. So you have to simply call the flatten operation. Hope you are able to understand. So we have a big box. Okay, that big box could be filled only in a sequential manner. So we have filled the first layer as a convolution layer with the help of a ReLU. Okay, then we have our second layer, which is actually a max pooling layer. Okay, with a filter size of 2 by 2. Then that's all is the layers. Then once that feature extraction layers is done, then we are moving over to the fully connected layer. So before moving over to the fully connected layer, we need somebody in between to convert the multi-dimensional data into a single dimensional data. So that person is nothing but the flatten. So once that is done, so we are here now. So we are basically here now. Now we need to build this part. Okay. So for building that part, we have the dense, the function which is basically used as dense. So in the dense, it has got various parameters, but we are going to give only certain parameters. Always understand, along with your convolution operation, your activation function will be mapped. Okay, and along with your dense operation also, the activation function will be mapped. Okay, I will tell you why. So in the dense operation, in the fully connected layer, you have something called units 128. What is this units 128? This units 128 is nothing but the number of the nodes here. Say you have a lot of blue circles here, right? So each of the blue circle which you can see here is considered as a node. Okay, so when you're converting this multi-dimensional data from the feature extraction part to a single dimensional vector, the number of the vectors which you get, that number is nothing but this unit. Okay, that is nothing but this unit. Okay, this unit. So you have so many number of units, and that unit has to follow. So there also, what you're trying to do, you are going to apply the rectified linear unit upon that's an activation function which you are going to apply upon the first dense layer. So this helps you to have a fully connection with the next layer. Okay, so see here each layer. So this first blue color layer is actually connected to all these brown color layers. Then second node is actually connected to all the other units in the second layer. Okay, so understand. So we cannot simply do that. We have to do that with the help of an activation function, because we do have a lot of features, everything. So we need to understand a bit more. Okay, we need to, what is that? So that is a major decision making center, right? So that decision making center will be able to identify the decisions properly only with the help of an activation function, right? Now the next one is nothing but the dense layer. So the dense layer will give you an output, whether it is bird, whether it is cat or dog. Okay, so my our final fully connected layer has got only one unit. That means that I should get only one output. My output should be either cat or either dog. Okay, and here we have used the sigmoid function. Okay, so the sigmoid function is there are different type of activation functions like softmax, sigmoid, ReLU, tanh. Okay, so the different type of functions are there. So accordingly, once you go in deeper, you will be able to understand about each and everything. So this is basically the what is that, the convolution, the complete model which you are building. Okay, so your model is a sequential model. So you have built you have actually kept a big dappa or big box. In the first box, what you have done in the box, you have actually kept the first layer, your convolution layer with ReLU. Then you have kept the second layer, that is, visualize that. Okay, the second layer wherein you have your max pooling. Then your feature extraction part is over. Then you are actually connecting. Okay, there is a bridge. What is the bridge? The bridge is nothing but your flatten operation, which will connect you to your fully connected layer. So in the fully connected layer, which is a major business intelligence unit, okay, where the prediction or the classification or whatever it is will happen, right? There you have got the dense layer. So the first, it has got 128. That is basically drilled down to just one unit to give us whether it is cat or dog. Okay, so your model is built. So once your model is built, the next operation is nothing but you need to compile that particular model. Okay, so understand there are see, basically in neural networks, okay, we are basically optimizing the data. Okay, what do you mean by optimization of data? So in optimization of data, what you basically does is that, say if you have a canyon, okay, if you have a canyon, you're trying to reach the end of the canyon where the loss function is less. Okay, so you are basically trying to find out the global optimum. Okay, what is the most optimal solution for those whole data? That is what our whole aim is all about. Okay, my model should train so many times in such a way that my model should be able to identify the most optimal solution. So whether if I give even a combined image of cat and dog, it should be able to identify that it is whether it is the higher intensities for the cat or higher intensities for the dog. So that much, learning has to be, training has to be done upon the image. Okay, so that is my aim. So I have so many different optimization algorithms like stochastic gradient descent, okay, the normal gradient descent, then mini batch gradient descent, okay, then RMS prop. There are different type of algorithms, ADA delta, ADABU, so many there. But in that, the most famous and the most commonly used one is the ADAM. Okay, so the ADAM actually is really good, and it's most commonly used because there are so many factors which comes in between, like momentum, acceleration, because it has to train in different ways. Okay, so I'm not going into that details. Okay, so so the optimizer basically commonly used is upon the images is ADAM, and there is loss, because we need to always make sure that, okay, the loss is lesser. The loss to the cost function, the cost is reduced and the loss function is lesser. So that is what our aim is. If you have a original image, if you have an older image, okay, if you are getting some particular image, how will you compare whether the gotten image is better? Because you compare the gotten image with the original image and see whether pixel by pixel comparison will be done, and you will understand whether which is better. So there is something which happens in between to identify. So this is nothing but the loss, which will help you to identify how good your model is. Okay, whether your model is able to reduce the loss. That is basically done with the help of this loss function. There are different type of loss functions. As here we basically go for a binary classification. We go for binary cross entropy loss function. Now the third parameter for the compile is accuracy. So what is this accuracy? Can we just go for accuracy alone? We cannot go for anything else. We can go for anything. It could be precision, it could be recall, it could be fmesh, it could be anything. Okay, but here, as we are in the earlier stages of learning, okay, what we basically does is that we go for accuracy. What does this accuracy do? This accuracy will help you to identify or understand the accuracy of the model which you have built. Understand? This will help you to identify the accuracy of the model. Okay, so you have we have just now built a model, right? So the accuracy of the model will be understood by this particular accuracy. Okay, so this is all about our model. Our model is just ready. So it is sequential model. You have convolution layer, max pooling layer. You have a flattened layer which connects as a bridge, and then you have your fully connected layer. So wherein you have got two dense layers, where the first dense layer has got 128 units, then it is actually drilling down to one single unit. Okay, then you have compiled the model. Now what you have to do now, you need to train your model, but before your data, that is mandatory. So I told you, say if you have some data, that data has to be pre-processed in such a way that data is actually usable by the model, right? So that is also a duty, right? So what we need to do, So we have taken our famous, what is that? The famous inbuilt function, which I have told you, the image data generator, which actually comes in pre-processing, which actually comes in the pre-processing.image. Okay. So what does it do? I told you, if you want to do any operation upon the image, then you need to call this image data generator. Say you are taking all the training data and then you're rescaling it. So this step itself is nothing but what? The normalization step. So in normalization, what are you doing? Say I told you in your RGB image, your values will range from 0 to 255. So you are making that range fall between 0 to 1 by rescaling it by 255. Okay. Now, shear range is one type of operation which could be performed upon the image. Then zoom range, horizontal flip. So these are the certain operations which you are doing upon the training data. Again, the same thing upon the test data. Then you are actually applying that upon the training set and the test set. That is what is actually done. So here your batch size is 32. That means, that is a in each and every epoch. We will hear about one epoch later. So in each and every epoch means you are traveling through you're traversing through your whole data set once. Okay, forward and backward. That is basically once. Okay, that is nothing but your epoch. But say if you have 8,000 data, you cannot make your system process whole of this 8,000 data all at once. Okay, so what you will do is you will split that 8,000 data into say 32 batches. Say 32 elements, images will be passed over to it to understand okay how the system works. So that is nothing but your batch size. Okay. So so by this step, so what you have basically done is that you have done some pre-processing. So is this a pre-processing which we do upon all the images? Not at all. Not at all. Okay, understand? This is just for this application. That's all. This is just for this application, and there could be done more, but we have limited the pre-processing which is done. So the major pre-processing which we are really interested in is this rescaling, because we want to normalize our image to 0 and 1. That is a major thing which we are actually very interested in. All the other things are just part of its everything is up to you. So that's done. So now what is the next one? The next one is nothing but we are going to so we have built our model. Now we have compiled our model, then we have made our data ready. Now what is the next thing which we need to do? We need to fit the data upon the model. Okay, that means we need to train the training data with the model. So that is what we are actually doing. So for that, we need to use classifier.fit_generator. There is one more function which will not be, in some cases, what happens is that this function will not work. So you will have to use classifier.fit. Okay. So here we can use this classifier.fit generator. Okay, classifier.fit generator. So what happens? So you are going to apply the model. Sorry, you are going to apply the model over the training data. So understand. So the steps per epoch is nothing but 250. Okay, and then you have something called epoch. So you are doing the training as 25 different rounds. Okay, 25 different rounds. And in 25 different rounds, you are in each epoch, you are going to give 250 samples. Okay. So basically, see, the steps per epoch is basically understood by, see here, you have your training samples. Say you have 4,000 samples, training samples. So 4,000 by the 32, which you have actually found, is nothing but this 250. So that means you will have to give 32 times, 250 to get your what? 8,000 images to be completed. So that is what actually is done here. So your steps per epoch is, so these are the batches. Okay. So these are the batches. So the number of the batches is 32 and your batch size is basically, or steps per epoch is basically 250 and the epochs is 25. So how will you decide upon this epoch as 25? Is it mandatory, ma'am, or is it fixed, ma'am? No, it is not fixed at all. Okay. According to each and every application, the number of the epochs changes. How can I find out, ma'am? Yes, you can find out by experimental basis. You have to do it. You have to trial and error for your system. You have to apply this different times. First, you could start with 10 epochs. Sometimes, your accuracy may not be good. Then you have to again change it to, okay, 12. Okay, sometimes when you change it to 25, what happens is overfitting happens. So you will not get any, after a certain stage, you will not get any difference in your model. Okay, the model will output the same values. Okay, so you have to try different epoch numbers and see which one will give you the better one. Okay, so and your validation data is actually given as test set, and this is the validation step. So validation step is basically the number of the validation samples. So your validation samples is again almost around 2000 divided by 32. So this is how you get this validation steps. So here, when you see this, this is not as simple as that. It takes a lot of time to do all this epoch. So this is the place wherein, you know, your system is highly likely to crash if your system does not have major, good configuration. So understand, this is the major part which you have to really worry about. So if you don't have major a good configuration in your system, this is the part where your system, because this is a lot of processing happening upon your system, right? It takes a lot of computational power, right? So what for this problem may be less because there is only 1,000 samples and I do have a GPU, so it doesn't matter for in my system, right? But when you are having just a CPU, because it will be really slow, it will make your system really slow and might crash. So this is where you have to really worry about. So if you see here in the first epoch, see, so the loss is given, the accuracy is only 0.59, and the validation loss and the validation accuracy is given as 0.67. You could see here, okay, 0.67. You could see here, right? So in the same way, in the second epoch, the third epoch, you could see the accuracy is actually increased. So that means that my model is actually getting trained in a better way. So you could see that as time goes, okay, as time goes, it is 0.77, 0.78. This is the accuracy upon the training set. Okay, it is actually increased. Okay, it is actually increased, and it is actually increased up to, so by the 25th epoch, it is actually almost around 8.84. Okay, so what I wanted to tell you is that the validation accuracy is 0.74, 0.75. It's actually increased. Okay, it's actually increased, and it is increased up to 0.76. Okay, and when you see the loss, you could see that initially the loss is more. Okay, initially the loss is 0.7, and as time goes, as the model learns in a better way, okay, you could see that the loss is actually reduced, okay, to a minimal range of 0.34. Okay, so this is how basically our system works. Say if I'm giving the epochs as 27 or 30, say I'm giving the as 30, say here you could see I could even stop the number of the epochs as, epoch equal to 20. Why? Because after here you could see it's like 0.82, 2.82, 4.826. So there is no major difference which is coming over here. So I could even stop my epoch as if I'm okay with the accuracy of 80%. Okay, if I'm okay with the accuracy of 80%, kind of 80%, I could even stop the number of epochs as 20. So where to stop or where to fix your epochs basically depends upon on an experimental or empirical basis. You have to trial and error and understand where it has to actually go. Okay, and now there is one more. So what you have done here, you have actually fit your model upon the training data set. Okay, upon the training data set. And this is the major. So your model is trained upon the training data. Now, what you have to do, now you need to understand whether the model is able to predict the value. Say, if I give this 1, it should predict it as dog. And if I give 2, it should actually, my model should predict it as cat. This is what I want to do. This is what I should actually get. So 1 is basically, so for that, the only thing which you have to understand here is that there is something called classifier.predict. Okay, so this is all the pre-processing which is to be done. Okay, and then here it is nothing but this is the other major function which you have to keep in mind. So classifier.predict, and when you're giving the test image, your test image is nothing but your dog. Okay, and it is predicting it as dog. And when you're giving the second image 2, it is actually predicting it as cat. So now you have actually built a convolution neural network which will be able to predict whether it is cat or dog. So a binary classification model using convolution neural network is basically learned here. Hope you're able to follow me. So this is basically done with the help of Keras, which is kept upon the TensorFlow, or which is based on TensorFlow. Okay, and Keras has got all the various functions available, right? So you don't have to implement anything. Your job is nothing but make your data proper, and you give the proper parameters to the system. That is only job for you. All the other job, everything will be done by by our model itself, okay, by the model itself. So once you have done that, the other major job is you have to build your model. So you have to first decide what your model is. Understand there are different type of models, okay? There are different type of models. There are different type of model classes for Keras, okay? So the first one is basically, what is that? You have, sorry, not this one. So you could just go to the Keras and check for that. So you have called function API. Okay, you can build your own ones, and you have got sequential. There are different type of sequential. There are different type of classes available. So in that, you are basically using sequential model. So you have a box, and in that box, you are going to add the different models. So that is what we have seen here. And once you have built the model, the next one which you have to do is that you have to compile it. Okay. Once you have compiled it and once your data is ready, then you have to use the classifier.fit. So this classifier is nothing but the name of the model which you're building, right? So classifier.fit. And then if you want to predict it, you need to use classifier.predict. Okay. So classifier, that name will change. Okay. Doesn't matter. It could be even model or it could be any name. Okay. Only thing is whichever be your model, that model.predict. Before that, you should have your model.fit. That's all. So these are all the different operations which you have to perform. Now, so hope you understood this particular example. Now, this is another example. Okay, wherein what you basically do is that this is a 10-class classification. Okay, this is a 10-class classification problem. Why it is 10-class classification problem? Because it is CIFAR data set. CIFAR data set. One second. It's a CIFAR data set. So there are different type of CIFAR data set. So in that, my net is slow, I guess. So this is kind of an example for that. Okay, this is kind of an example for that. So wherein, one second, it will come. Okay, it will come. So you could see here, see in this particular data set, you could see there is an aeroplane. Okay, there are a lot of airplanes. Okay, then there are a lot of automobiles. Okay, then there are a lot of birds. Okay, then cat, then deer, dog. So different type of animals, automobiles, you know, so many things. So this is kind of a 10-class classifier. So that is nothing but this CIFAR 10. So I just wanted to tell you that, say whether it is a binary classifier or a multi-class classifier, the method that we are going to follow is all the same. When you are going to build, okay, when you are going to build a deep learning model, it's all the same. Okay, so see here, what you're going to do is that here also you are importing all the different. So here I just wanted to introduce you with certain things. That's why I know I'm taking just progressive ones. Okay, so here you are actually importing different models. And here also we are using sequential model. And here we are having, you know, this activation, con2D, max pooling. We have dense layer, we have flatten. The only thing which is actually new for us is nothing but this batch normalization. That means I'm normalizing the data batch wise. And there is something called dropout. This dropout is nothing but to prevent the overfitting. What is this overfitting basically? So this overfitting is nothing but if you have a model, okay, if you have a model, if you train that model with all the different possibilities, will there be something new for that model to learn? No, right? There will not be anything new for the model to learn, right? So that is nothing but so what will happen is that whatever data you give, it will try to fit everything. Okay, it will try to fit everything, and that is nothing. That problem is called as the overfitting problem. Okay, that is nothing but the overfitting. So what happens is that you will not be able to, okay, differentiate what is actually the actual data and what is actually the not, you know, you know, so the model actually tries to fit everything. Okay, so basically what happens is that the efficiency of the model will be reduced. So in order to reduce that, what we will do is that we will come out with a term called dropout. Okay, so dropout means, say, I will tell you in simple way. So if I have 100 data, okay, I will train my data. Okay, it's say in your training set, if you have 100 data, I will train my model only with 80. Okay, that 20 you just leave it. Okay, you don't train that 20. You don't train the whole system upon the whole training data. I don't want that. Okay, so I don't want any overfitting to happen for the model. So that is nothing but dropout. So I will say that 0.2 or 20% of the data, let it be, you don't train it. Okay, you just leave it. Okay, so that is nothing but the concept of dropout. Okay, then you have something called max norm. So that is also a different kind of that is normalization technique. Okay, then you have something called NP utils that you will see because it is used for the categorized categorical data. Okay, so the seed is nothing but for you to just start with. So don't worry about all this initially. This is just kind of some random weights which is designed to kind of stuff. So you don't have to worry all those now. So see here. So do you have to download the data as such, the CIFAR 10? No, because see, understand this program is basically taken for you to tell you that, okay, you have something called keras.datasets. Okay, you have something called keras.datasets, and you can import most of the data are there already in keras.datasets. Say if you want to start working with the data, okay, different data, most of the data are already there in keras.datasets. So you could just go to the Google and search for keras.datasets. It will give you all the list of the datasets which are already available in keras. So for this, for you to show that, for you to understand that only, I have taken this thing. So here I'm not downloading or I'm not taking anything. I'm just, using the dataset which is already there in keras.datasets. I'm just importing it. That's all. Hope you're able to understand that. Then how can I load that? Okay, I can load that by splitting the data into training data and the testing data. So, and how can I do that? I can do that with the help of the function called load data. Okay, so this CIFAR10.load data function will help you to load the data from the keras.dataset. Now, how will my data look like? Understand, even though it is images and everything will look like what matrices. So understand, so this is the data, right? This is the data, and I could see all the values which are ranging from 0 to 255. So what kind of an image is that? That data is nothing but a color image. So this whole thing is your data. Then comes the next one. So you are going to normalize the data. Understand the basic data type which is used in the in deep learning is float 32. So that is just for your CPU to function properly. That's all. You don't worry much about it. Okay, it's just an input feature which you have to do that. But understand, when you are doing the normalization, this is exactly the same. So what you're doing here, you are taking the training data, you're taking the testing data, you are dividing it by 255. So what will happen basically? Your data is now within the range 0 to 1. It's as simple as that. So this is the step where you does for normalizing it, okay, to make the data between 0 and 1, right? Now the next one. So this is again, say, what is it? Yeah. So I'm just leaving this NP utils here because NP utils, I think it will make you just it is just to work with the categorical data, because say here you have 10 different categories, right? You have 10 different categories here. Say you have aeroplane. So this picture will be labeled as aeroplane. This picture will be labeled as automobile. So say if you're taking this picture, that will be labeled as what? Bird, right? So each and every picture is basically categorized. Okay, it has to be categorized, right? So in order to do that, basically we have something called np.utils to categorical. So that means that this NP is nothing but your numerical Python, okay, NumPy. Okay, so NumPy has got something called utils. It will convert that into a categorical data. So you have to train the data categorically. So that is basically done with the help of np.utils. Okay. So understand, so if you come across this kind of terms, it should not be new to you. At least, you should be able to go ahead and search and find out what it is. Okay. So that's all. And then comes, you are going to build the model. So when you're going to build the model, okay, you have something also. Here also, you're going to build the model in a sequential way. So your model is basically a sequential model, right? Now you're going to build the model. So how are you going to build the model? So you have a convolution layer. Okay. So again, you have a training data. So this is your training data. This is the shape of the training data. Okay. And then you have 32 filters and the filter size is 3 by 3. Okay. And then there is something called padding. Okay. So padding means padding is basically done for the what is that? In order to retain the shape of your original image. Because what happens is that when you actually basically apply a filter, basically here, if you see, when you apply the filter upon the data, what happens is that the size of the data is actually getting reduced. Okay. So they have actually introduced a concept called padding. Okay. So in the padding, what happens is there are different paddings available. So if you're keeping the padding as same, you can retain the shape of your original image. That is basically done with the help of this padding. So that is again another area wherein you could actually, it's kind of, one session which you could take upon padding itself. So it's like that. So just understand, when you apply filters upon the original image, the original size of the image may change. So these are all some terms which you will come across when you are actually searching for deep learning algorithms. Okay, so that's why I'm just touching upon all this. And then comes the activation. So the activation, I told you, you can combine it with, you could just put a comma here and make activation ReLU. That is also possible. Yes, if you want to do it separately, that is also possible, right? So this is nothing but your convolution followed by activation. Now, what is the next one? See here, I told you there is something called dropout. What is this dropout? This is just for you to prevent the overfitting. So here I am actually considering, like, 20% of the data, even if you drop out, I'm okay with it. My model should not overfit. That is my aim. So I have given the dropout as 20%. Okay. Now, next one is batch normalization. So batch normalization is nothing but in all the different layers, okay, I need to normalize the data. Okay, I should have a same distribution in all the layers, because you know that your normal distribution just follows a bell curve, right? You know that because normally you does that for the student marks and everything. So normally we does this normalization. We all know that how it goes. So I want the distribution of the data in all the layers in the same way. So that's why we go for this batch normalization. And then again, this is the next layer. So these are all the different layers. Hope you're able to follow me. So the first layer is actually convolution layer followed by a ReLU. Then the second layer is a small dropout layer, which comes as part of it. This part basically comes as part of your convolution layer. The next one is nothing but the second convolution layer. Then again, the third one is basically a max pooling layer. Okay, so max pooling layer is also added with. So in the max pooling layer, I am again considering a dropout of 20%, and the distribution has to be normal distribution. Then I have again got another convolution layer where you have your what is that the 64. So here it is 64 filters, which is of the and it is also the each of the filter is basically 3 by 3. Okay, and here again you have a max pooling layer, then followed by this one again. So you have got so many convolution layer and max pooling layer combinations here. Hope you are able to understand. So once you have built this complete model, so this whole thing is your model. So once you have built your complete model, then before going over to the fully connected layer, what do you want? You should have a flatten, right? You should have a small flatten operation which comes in between. So that is what this is. So you have your flatten operation, okay? And that should also follow what? The normal distribution. And then, sorry, that should also should not overfit, okay? Then comes the dense layer. Dense layer is your fully connected layer or the business intelligent layer, okay? So you have got 1, 2, and 3 different dense layers, okay? This is the first dense layer, then followed by the second dense layer, then followed by the third dense layer. So understand, whenever you see a dense layer associated with the softmax function, okay, the softmax function will help you to come out with a probability. So what do you mean by probability? Right? Say you have 10 different classes here. So this softmax function will tell you, say aeroplane is 50% of the whole data is 50%, okay? And this is 90%. So that means, say if you are given one particular image as input, and if you are making your model identify what that image is all about, it will also tell you a percentage of similarity. Say if I have given an say aeroplane image, say for the air, maybe it will be 60% similar. Say for bird, say if it is a flying bird, it can have almost 70% similar. And for the cat, deer, dog, and all, it will be 30% or 20% similar. So that is nothing but the concept of this softmax. It is such a beautiful function. And now comes epochs. What is this epochs? I told you. So yeah, before moving over to this, understand this is the whole model which you have built. So all this are nothing but the model which you have built. Can we restrict the layers? You can even restrict the layers. You can even add more number of layers. It's all up to you. Okay, it's all up to you, and upon your data set, upon the application, upon your system's capability. It depends upon so many things. Now, You are setting the epochs as 25 and the optimization function as Adam. I told you this is one of the most common algorithm which is used for, and it always provides greater performance. And then what is the next one? Next one is nothing but compilation, right? Compilation of the model which is generated. What is the name of the model which is generated here? The name of the model itself is model, right? Name of the model itself is model. So you're compiling the model. You're compiling the model with the loss, the optimization function, and you are just interested in getting the accuracy of the model, right? So here, this is the model summary. See here how many layers are there. So you have this is nothing but the model summary. So you have your convolution layer, activation function, again a convolution layer, activation function, dropout. So the complete summary of how your model. So many different layers are there in the model which you have built. So see here the number of the parameters which you are trying, the number of the training parameters. It's so huge. Okay, it's such a huge model that you have designed today. Okay, so now what you have to do now, you have to, your next aim is, so once it is compiled, then the next aim is nothing but you have to fit the model upon the training data. Okay, upon the training data. So what you have done is that you have trained this particular, see almost 5,000 samples are there in each epoch. Okay, you are using actually 5,000 samples. You could have, if you want, you can actually batch it also, nothing wrong in it. Okay, you can batch it and you can give a smaller number of batches for your training. So this and all will take that many number of, that took so many time for so much of time to complete all this operation. So once you have done this, you could see that you could evaluate. So here I'm not predicting anything, right? I'm not predicting anything. I'm just evaluating my model. Okay, so you have something called model.evaluate, which will help me to give the score. Okay, this score, this 0.83 is nothing but the score alone. Okay, it's nothing but the score on the validation. Okay, the score on the test. Okay, 0.83. So it will give you that your model is able to predict new data with an accuracy of 83%. So this is nothing but what another example for CNN. So see, understand, it's all the same. It's all the same. So you have your you have to just import all your what is that layers which are needed. You have to import everything. Then if you want to do some operations upon pre-processing upon your data, you better do that initially itself. Okay, so all these things are part of the pre-processing. Then you need to build your model. So it's a sequential model. So you're building your model as such, right? So this is the whole model summary. Then you are trying to fit that particular model here. You're going to try and fit that particular model. Then you're going to evaluate, compile that model, fit that model, and evaluate or predict that model. So this is a sequence which we follow. Now we have different. So I just wanted to tell you. I'll just go a bit fast. So this is again the same model. Okay, the same dog and cat, thing. So now by seeing this, you will be able to understand it's all the same, right? So you could see here the sequential model, count 2D. So it's all the same. Okay. Now here what we have done is that it's the same dog and cat. So till here you will be able to understand now, right? It's all the training data is taken and it has actually done some pre-processing. So it is divided the data as training and the testing. So that is what we have done till here. Now, one thing which I wanted to tell you is that there is something called transfer learning. Which is very commonly used in your IoT as well. So in transfer learning, basically what we do is that, okay, so we have certain models which are already built by somebody else. Okay, there are certain models which are already built by somebody else. So what we can do is that we can better utilize those models to come out with new data. Okay, we can use that models to apply upon our data, right? So that is also possible. So such a kind of variant is called VGG16. Okay, so VGGNet is developed by a person. Okay, long back. It's almost in 2015 or 13, I guess. Okay, so he has actually made it as an open source and it is now part of Keras as well. So see here. So this model, I am actually importing this particular model from Keras.applications. Hope you are able to understand. This is a model which is built by somebody else. Okay, so that model I'm actually importing from Keras.applications, and then I'm just using that particular model in order to train my system. Okay, now when you see here this part, when you see here, so this is such a simple experiment, example to show you how you can use the already existing model. Okay, so understand, this is a new model. This is the model which I'm going to build for my application. Okay, so here what we have done is that we have made our model sequential. Now, am I coming out with convolution, max pooling and everything? No, I'm simply using this VGG model. Okay, so this VGG model has got a lot of convolution, what is that, convolution and max pooling operations. One second, VGG model. One second, see here. So this is an example for your VGG model. Okay, so this VGG model is basically a variant of, okay, this is basically a variant of what? A variant of convolution neural network. So, but this model is built like that. This part you cannot change. This part you cannot change. Okay, but this part basically looks like this. So somebody has built this model, and this model is basically like this. So it has got a convolution layer, then again another convolution layer, max pooling layer. So this is a combination of this. Then you have 3 dense layers. So this is the VGG16 model. So in this particular application, what we have basically done is that, okay, what we have done is that we are not going to develop any convolution or any other different models. Instead, what we have done is that we have simply incorporated this VGG. So when our model sees this VGG, what it basically happens is that it internally just abstract, it just goes and expands all the layers. So it is a function. It is a function in keras.application where in this application, all the different layers and everything is already there. Okay, and its weights is basically incorporated from ImageNet. Okay, so it will be a .h5 file. And then what happens then after that? So it has also got some dense layers and everything inside. So after that, it has got then the connection. Okay, it's your flattened. Then again, you have got 3 different dense layers. So it's kind of a better prediction which is happening with this particular model. So this is the model. So this kind of way also you could build the model. It is not mandatory that you have to build each and every layer one by one, and you can also use those models which are already available there. So this is basically a variant of your CNN model, okay, wherein you could use for your applications. Okay, so this is one way. And then is the rest of the things all similar? Yes, it's all similar. You have to do a compilation because this is a new model. It is a new model which uses VGG, right? So you need to compile this particular model. So when you are compiling this particular model, again you have 3 different parameters. So you are using a CTC here, CTC loss function. Okay, and here you are using Adam, and again I'm finding out an accuracy. So when you see this, this is your VGG model. So this is your model summary, right? This is so heavy, that's why we restricted it to see. If you want to, one more thing which I wanted to tell you is that, say you're building a model here, right? And once you fit, that means your model file is generated, your model is generated. Okay, this is one very important thing which I wanted to tell. Okay, till now, okay, if you do this model.fit, what will happen? You will get a model, right? So when you get that particular model, if you want to save that model, you can use this as model.save. So once you train this, so this particular model, so this is your new model. This is your new model which is generated. So you can use this new model for using some other model. So instead of this VGG, VGG, instead of this particular part where you have used this here, instead of this particular part, you can use your model and you can apply it. That is also possible, right? So this is the new model. So this model can be used for your next application. That is also possible. So understand, whenever you are building a particular model, if there is a chance that you will use that particular model, because training this model is not easy. Okay, training this is the training part. Training this whole model may take hours and hours of time if the data is too much. Okay, and it is completely heavy upon your system. So if you want to save the model, better use this model.save in between, whether you use it or not. Otherwise you can just click delete. That's also possible, right? So you can save the model so that at least you don't have to train it again and again. Instead, you can use this .h5 file for using it for your rest of the applications. Okay, so that's also, this is an application. So this, just I wanted to tell you that this is something you are using for cat and dog classification. But here, instead of building your own convolution neural network, you have used an already existing one. And this kind of using your already existing one for the applications and all the things are called as basically the transfer learning. Okay, now what is the next one? Then I'll just So there are so many examples like that. And yeah, this is another example. So do we have only VGG16? No. So there are so many variants for convolution neural network. Okay. So you have VGG16, you have Inception, that is your Google Inception, you have ResNet, you have MobileNet. Okay. You have different type of applications for that. Okay. Different type of variants for that. So any number of variants, what you have, see, this is actually the Google Colaboratory which I have used. Understand? This is Google Colaboratory which I have. This is not the traditional one. Okay. So what you have to do is that you have to simply import. So where can I get all this applications, ma'am? So understand, all these variants are already available in keras.applications. Okay. Keras.applications. What am I doing? Import VGG16, right? And here, if you see, it is keras.application import Inception v3. Why it is v3? Yes, Inception has got various versions. Okay, and the most commonly used version is Inception v4, and which is one of the most highest, which is a model which gives you the highest accuracy across all the other CNN models which is already available. Inception v4. Okay, so there are different type of models available, and this is your importing this ResNet. This is also your importing, okay, which is also your importing from keras.applications. Understand? So there are different type of applications. So here, if you see, this is also an application. Say I have taken the same application, the dog and the cat classification, but here we are trying to see, this is the image. Okay, this is the input image. So what we are basically doing is that we are giving this input image. We are making all the different models predict, okay, how closer is this image with the rest of the dog classes. That is what we are doing. So we are doing a pre-processing of all the images. We are actually doing the prediction using all the different models. So you could see this is the VGG16 model. So in the VGG16 model, you could see it is 0.59% closer to Labrador. Okay, and there is something called golden retriever. So it is almost 24% closer to golden retriever. Okay, and there is something called Tibetan Mastiff class. So where it is 0.28% closer, and bloodhound is there. So it is almost closer to, so like that. So say you have different dog classes. This VGG16 predicts what is the similarity of this input image with all the other classes. That is what we are doing. Okay, so that's about your VGG16. And then when you take Inception v3, it gives an accuracy of almost 0.99%. So it does not alone take the, what is that, the picture information alone. It has also got some semantics collected. Okay, and then golden retriever 0.0078. So when you see this itself, you know that okay, Inception v3 actually works better. Okay, and then Rhodesian Ridgeback, okay, it is giving some very less similarity, right? And when you see ResNet, you can see it is only 0.70%, golden retriever point, so like that. And then there is also called MobileNet, which is 0.93. So MobileNet is better. And then the most efficient, the prediction which is done is by the Inception v3 model, okay, which gives it is as close to, it's a lab, okay. So that is how this models work basically. So you can, there is nothing that you need to use or you need to build each and every model from the scratch. It is not necessary that you need to build each and every model from the scratch. Okay, you can also use the already available models which are already there in keras.applications. It is just that you should know how to use it. Okay, that's all. That's one thing. And then what is the next one? Yeah. Okay, then I think I will quickly go to autoencoders, because I think better than RNN. Okay, you will need autoencoders a bit more. Sir, is it too much? Shanmugesh sir?
Sir, ma'am?
Shall I continue, or is it too much of information overload?
I think they are overloaded, I think so.
Yeah, then it's fine, sir.
But
then it's completely fine.
One thing, madam, I have fulfilled the requirements of the participants through you. I'm sure that because this is one of the main important topic what the participant asked initially during the first.
I think they will not ask anymore.
So through you, I have fulfilled their requirements. I'm satisfied with that.
Okay, sir. So because see, it is very difficult for me to even tell the concepts and then take them through the what is that demo. It is very difficult. It is very difficult because this is something which I have gathered over the years. I'm trying to drill that down to a smaller session of 1 hour or 1.5 hours. It is too much for them also. But one thing which I wanted to tell you is that, see, just understand, all these things could be done by you in an easier way by just searching in the net. Everything, anything and everything which I am showing you here is, which I have worked, all these materials and everything which it is nothing. It is everything there out in the internet, because when we started learning all this, we didn't have any resources. Initially, when we started learning, we had not got even any resources. But understand, those people who are actually trying to, if you want to learn now, all the information and the resources are there out in the internet. So now you're all actually lucky. Okay, so there are so many problems and applications, everything available. So you could just start, it is just that you should have a will to work upon it. When you see some errors will be there. Please understand. See, when we start working with that, the one major thing which I wanted to tell you is that don't get scared by errors. Okay, errors or mistakes will make you learn better and make you take your step to next level, help you to take to the next level. That is one thing which I wanted to tell you. So you should get errors, you should end up in mistakes, you should try in all the hard ways, go here and there, understand, get the help from that person, this person, Stack Overflow there, here and everything. But once you understand and try to rectify those errors by yourself, then you will never forget it. Because this kind of errors will propagate in one way or the other in one program or another program. So it's all the same. So once we understood what that error is, then it's all simple. Then you could just, oh, this is the same one which I have seen, now I know. Okay, then now you know that now you're ready that you could deal with it. So it's all that. So always make mistakes and learn from it. Okay, don't just tell that, okay, Sini ma'am have asked to learn, make mistakes. Yes, you should make mistakes, but please learn from it and use it in a better way. That's all. So I think, sir, I think, if it is overloaded, we will better, wind it up.
Yes, ma'am.
Yeah, that's
almost fine. It is lunchtime. We need to start at 2 o'clock. Second session, next session also.
Oh yes, no problem. So that's all. So everyone are hungry, and So I hope everyone will utilize. If you have any questions or anything, please ask. You can ask it if you want. If you want to ask any questions. Or
if at all, if any question means, I will share with you, madam. No problem.
Yeah, no problem.
I will connect and share with you.
Fine. Yeah, that's fine. That's fine.
Okay, madam. So without much delay, let me come to the end of this session. Sure. So I thank you once again, madam. Again, I repeating that with one of the main requirement for the participant is to have a demo session. So with the help of you, I have done that. Thank you very much. Now let me invite Mr. Abraham sir for the vote of thanks.
Thank you, ma'am, for the session. Thank you for sharing your experience with the IoT application with using deep learning and expert learning. Thank you very much. On behalf of Mechanical Engineering Department and Vishwadhi Engineering College, I express my sincere gratitude to you, ma'am.
Yes, also, thanks a lot for this opportunity.
Thank you, ma'am. Thank you, ma'am. Also, I thank all the participants for attending this session.
Thank you, ma'am. Thank you once again.
Thank you,
participants, for the patient hearing.